Hi, I'm Tom, and I'm here to talk to you about bug bounties with Bash. So, I'm a security researcher at Detectify, which is a lovely thing to be able to say. I'm Tom Nom Nom online, basically everywhere. I'm a mediocre bug hunter, and just as a bit of a disclaimer, this talk is adapted from a workshop they ran at B-Sides Leeds a couple of years ago. So, if you happen to be there, then a lot of this will look familiar. So, first off, obligatory disclaimer, the law is kind of a big deal, and you should not attack any systems that you don't have explicit permission to attack. If you use any of these techniques to do illegal things, nothing to do with me. So Bash. Bash is a shell. And a shell is a thing that wraps a kernel so that you can launch processes. It's actually a botany metaphor, which I think escapes some people. And there's many other shells as well. So there's ZSH, which I believe is the default on macOS these days. Fish as well, KSH, CSH. Even Explorer.exe in Windows is something that counts as a shell. Personally, I like Bash for a variety of different reasons, but really mostly it's personal taste. So why would you want to use Bash to do bug bounties? I guess one of the first answers to that is, well, why not? You can, and part of being a hacker, as far as I'm concerned, is doing the things that you can, even if there isn't necessarily a good reason. But also, there's many purpose-made security tools out there that I often find they do nearly what I want, but not quite what I want. So having the ability to quickly and efficiently automate tasks and write my own tools is something that's really useful. And sometimes you just got to make a tool. Another thing I think is worth addressing is, why not GUIs? Why would I want to use some command line text-based interface? And GUIs are nice. And one of the things that they do especially well is they provide really great discoverability. You can look through all the menus and find all of the options that are available to you. But if they don't support your particular use case, then you're kind of out of luck a lot of the time. Some GUI applications provide extensibility through plugins, but then you're back to writing text. Whereas the shell lets us join things together and build our own tools in a just-in-time manner, which I'm a big fan of. So I'm going to show you a couple of Bash basics. And this is the bit where hopefully, people can say, ooh, and ah, and all that sort of thing, like you're impressed, even though it's not really very impressive at all. So this is a terminal. This is mine. It's running on Ubuntu on my local machine in the Terminator terminal emulator. And its main sort of purpose is that I can run commands by typing the name of the command. So the ls command, for example. And I can modify the behavior of those commands with flags like the -L for ls flag to give a list output. And what's actually happening there when I run ls is a binary, which is in /user/bin/ls, and looks kind of like this, just a whole load of gobbledygook. If we open it in a text editor, all this binary stuff is being loaded into memory by the kernel. That's what's happening when we're typing commands. And there's a whole bunch of different commands that we might use day to day. So grep is something I use a lot to search for patterns in files. Sed for editing input streams of text, which is something we're going to look at. Awk, which is a general purpose text processing language. Again, we're going to see a couple of examples of it in use. Cat to concatenate files, or more commonly just to output them. And there's a whole bunch of other commands as well, far too many to list, but I wanted to kind of give a little bit of an overview of some of the common ones I use all the time. So one of the core concepts of the shell is I/O streams, which is just text going in and out of applications. So a Linux process has these three standard streams. Standard in, or standard input, which is file descriptor 0, if that means something to you. And there's also standard output and standard error too. So standard input by default is attached to your keyboard. So when a program tries to read from this input stream, it's reading data from your keyboard, by default at least. A standard out and standard error are attached to your screen by default, so you just see the output of them appear in the terminal, like we did when we ran ls just now. But the shell lets you redirect these standard streams. So you can reconnect, for example, a file to the input of a command, so to the standard in, but you can also connect the standard output or standard error, or both, also to files and to other processes as well, which we'll see in a second. So as a real quick example, if for some reason we wanted to take the output of ls-l, we could use the greater than symbol to redirect the standard out of that command into a file called output.txt. We can see we saw no output on the screen this time, but if we use cat to cat the output of that text file, we can see the output that was saved. And interestingly, you can see the text file was created before ls managed to run with a 0 length, which I think is quite interesting. We'll see some more examples of these being used soon. There's also a couple of subshells tricks you can do. So this first one, returning the output of a command as a file descriptor, can be quite useful. But this second one especially, returning the output text of command, is incredibly useful. So earlier on, when I wanted to, for example, open the ls binary in Vim, I had just run which ls to get the location of that binary. And in this case, I used my mouse and I copied and pasted it. But just as an example, we can wrap this which ls in the dollar and the brackets to get the output text of it and pass it as the argument or the parameter to Vim and get exactly the same behavior. And if we press up once and see our history, it still looks like that, but that can be a really nice shortcut to use. So this is, a security conference, so we should be talking about security stuff. And I'm a big fan of recon, and one of the first sort of recon tasks that everyone thinks about is enumerating subdomains. So I want to demonstrate how you might build your own subdomain brute forcer using Bash. And really this is mostly an example to use for writing things in Bash. In reality, you can use these techniques to write whatever you want. So we're going to need to target a word list and Bash, and we'll see how we get on. So we have our subdomains.txt file, which I pre-created, and it's not a very long one, just for the sake of keeping these examples running quickly. And what I really want to do is take these subdomains and prepend them to some domain and see if they resolve. So how am I going to do that? So one of the first things is we want to know, how can we figure out if a domain resolves? So we could use this host command, for example. So here we can see it. We run host example.com and we get some output. It tells us what the IP address for example.com is, and the IPv6 address too. Or also we can see if we try and look up a domain that doesn't exist. I'm not quite sure why no one's bought that one yet. We can see that it's not found, and we get this annex domain error. And for humans, it's really, really easy to tell whether that worked or not. But how do we do that programmatically? And the answer is a thing called exit codes. So every command that you run in the terminal has an exit code. And you can view it by doing echo $? And if it's 0, that means the command worked. And if it's anything else at all, that means it didn't work. So when we were running ls, for example, if we echo $? We can see the exit code is 0 because it worked. But if we do an ls on some directory that doesn't exist, we get an error message, but also now the exit code is 2. And we can use those exit codes to handle programs working or not programmatically. So to do that, we're going to use a thing called a conditional, and this is the general form of it. So we have the word if, some command, a semicolon, the word then, and then some command to run if the original command worked, and then fi, which is if backwards, which is a little quaint and maybe a little confusing for some people for a way to end a conditional, but that's just the way it happens to be. So let's try and do an example with our host command. So let's take, for example, example.com, because that's what it's for. And we know this resolves, so the exit code is 0. And we can put that into a conditional by saying if host example.com, semicolon, then echo, let's say it resolves, and then the fi. So if we run this, we can see example.com has some addresses, and also it says it resolves. And if we swap out example.com for something that doesn't exist, we get that error, and note that we no longer get a message to say it resolves. So that's kind of the first piece of the puzzle for us. Well, it's kind of a little bit messy in a way. So we have all of this extraneous output that actually we don't really care about. I don't need to know the IP of this particular domain. I just want to know whether it resolves or not. So I'm going to use that IO redirection that we talked about earlier on. An ampersand greater than means redirect standard output and standard error, which are the two output streams, to some file. And the file I'm going to use is a special file in /dev called devnull. And you can think of that as a little bit like a black hole. You can throw data into there and it just disappears forever, never to be seen again. So when I run this command now, you can see I get the message saying it resolves, but I don't get all of that extraneous output that I didn't particularly want. So yeah, tidying up a little bit helps. The other thing we're going to need to use is loops, which look kind of like this. So there are other loops too, but I'm going to focus on while loops. So we have the word while, and then some command, and while that command works, that is to say its exit code is 0, I'm going to do something, some arbitrary command that I can run, and then I have the word done too. So as an example of using that, I might take, for example, this list of subdomains that I have, and use those as the input to a while loop. So I'm going to say while read, and read is a command that reads a single line of standard input and puts it into a variable, and you get to name the variable, and I'm going to call it sub. So I'm going to say while read sub, I'm going to echo $sub, which is how you get the contents of a variable in Bash, and I'm just going to use one of my domains, spt.uk.net. I'm going to echo that out, and then there's the done. And then I'm going to use the less than to attach the contents of subdomains.txt to the input, the standard in, for this while loop. And we can see that I've got an error, and that is because I missed the word do right here, which was a silly mistake to make. So here we go. This is looking pretty useful actually. So we've taken each line from this piece of text, and we've added this .spt.uk.net to it. Which is, looking kind of like the sort of data that we want. So that was the more demo time, and there's another slide showing you basically what I just did. I took care when I made this presentation to have slides for things in case I just couldn't make them work and couldn't fix all the syntax errors that I came up with. I think that's a really important idea. So now really we want to put this stuff together, and there's an example here of what that looks like, and I think that's getting a little bit messy. So actually I think we should talk about shell scripts. So these long complicated commands can be a little bit of a pain to type, and the good news is we can take basically any command and we can put them into a text file, which by convention often ends with .sh for shell, and we call that a shell script. And I'm going to call this root.sh, and I'm going to paste in that command that I just wrote. And at the top of the file, I'm going to put in a little cantation that looks like this: a hash and then a bang /user /bin/bash, I think is the right path to bash. So what this is a thing called a shebang, and this actually tells the kernel what shell or what interpreter should be used to execute this text that comes next. And here's a nice little Vim trick for you actually. If you can't remember the path of the command, I can hit exclamation mark twice and I get a little prompt that looks like this with the colon, the dot and the exclamation mark, and I can run which bash, which is a command that tells me the location of the bash binary But this little vim incantation runs a command and then inserts the text into the document, which is quite useful. So I have that. And so this should work in theory. Except I think we're going to hit a little issue at some point, which is if we try and run it by doing / and then brute.sh, it's going to say permission denied. And if we do an ls on it, we can see here these are the permissions for this particular file. And we have read permission and write permission for the user. But there's one missing here, and that's the execute permission, and you need that in order to be able to execute these shell scripts. So let's use chmod or change mode command with the parameter +x, which means add the execute permission for brute.sh. And now if we run ls on it again, we can see we have execute permissions on it, and we can run our shell script again, and it all works nicely. Okay. So let's continue looking at this. And really what we want to do here is join together the conditional that we wrote and this while loop and use them both together at the same time. One of the nice things about the shell script is I can actually introduce line breaks now. So instead of having everything on the same line and being really difficult to read, I can spread them across and use a little bit of indentation to make things a little bit easier. So while we're reading subdomains from the input, at the moment we're just echoing them, but actually we want to do that conditional that we were doing before. So let's say if host sub.sbtuk.net, then, and there's the fee, then we will echo it out, but only if it resolves should it be outputted. So let's try and run our script again and see if it looks any different. Quite different. So we have a few lines of output telling us about IP addresses and things like that, and we have a lot of these lines missing, so presumably those ones don't resolve. So we need to add in that little redirection trick that we used earlier on to say redirect all of standard output and standard error to dev null, and then run again. So now we can see we have just these 4 subdomains that resolve. So admin.sbtuk.net, test.www. and m. They all resolved, which is good to know, I guess. Except, you know, this script is kind of useless. Like, I don't really want a script that just checks just these particular subdomains in the file called subdomains.txt for this one domain. We need to make it a little bit more generic. So one of the things that's kind of given to every shell script is the arguments that were given to it. So we have $1, which is the first argument, $2 is the second, and we can reassign them into other variables. So I'm going to make a new variable called domain and set $1 to its, or set its value to $1, which is the first argument to the script. And here where we have sbtuk.net, instead I'm going to say $domain, and I'm going to do that here too. So now when I run the script, it's going to have no output, but I can provide the domain name as the argument to the script, and it works just fine. And I can swap this out for a different domain too, and I can see that that works as well. But we're still always reading from this subdomains.txt, and I don't want that. So the fix for this is actually just to delete it. So if I try and run the script now, we can see it's just sat here waiting. And if you remember earlier on, we said standard input or stdin is connected to your keyboard by default. So actually, if we just type the subdomains that we were wanting to test, then that works too. And if we test one of them that doesn't work, we can see it doesn't get reflected back at us. But we can use this less than symbol to connect our subdomains.txt to the standard input of our shell script, and we can see that work too. There's actually another way that we can do that I use quite a lot, which is a thing called a pipe. So This is not an I or an L, it's the pipe character. And you can think of it as meaning take the output of this command and pipe it into the input of this command. Really what it means is to attach the standard output of one command to the standard input of another. So we've made our shell script and we've made it generic. So actually we have our own subdomain brute forcer now, which is really nice. And there's just that one little check on permissions that we already handled it. So one of the other things that I think I would like to do with a list of domains for a bug bounty program would be to check for what's called dangling CNAMES, so, or subdomain takeovers, I guess is the terminology most people use. So here's an example. So we have the host invalid.sptuk.net, and we can see we get an NX domain error, which means it doesn't resolve. But if we run a slightly different command and look up the CNAME record for this invalid.sptuk.net, we can see it's actually an alias or a pointer to this other domain, which is not registered. It doesn't resolve. And that's why we originally got this NX domain error. So in this case, if I was to go and register this particular domain, I would have control over the content of invalid.sptuk.net. And that's generally considered not to be a good thing. The impact of that would depend entirely on what else is on sptuk.net, but we won't go too much into that now. So here's the plan. We're going to check subdomains for CNAME records, and we're going to check if those CNAMEs resolve. And if they don't, then maybe we've got profit on our hands. So let's give it a go. So I'm actually going to start from our brute.sh script and make a cnames.sh, and we'll open that up. And we're still going to have kind of a very, very similar thing going on here, but we want to look up the CNAMEs instead. So let's use the command line to figure out what our command's going to look like. So it's going to be invalid.sptuk.net is our example domain that we're using. And this is the piece of information that we want. We want to take that and we want to run it against host like this. So the first thing we need to do is isolate it. And I'm going to do a couple of things here, one of which is I don't know if there's going to be any other lines of output for this domain. So I'm going to grep or search for patterns in the output specifically for this an alias. So I know I'm only ever going to get these particular lines. And then I'm going to use the awk tool you mentioned earlier on, that sort of text processing language. So awk gets given a program which looks like this between brackets, and it's going to be a very small program which is going to be print $nf. When $nf is a special variable, it means the number of fields. So in this case, the number of fields is space separated, so it's 1, 2, 3, 4, 5, and 6. So this would be the same as writing $6, but what it really means is the last field in that particular line of output. So in this case, we get just the domain. And another thing that we mentioned earlier on is that we can use this Subshell trick to set the output of a command to a variable. So in this case, I'm going to set it to a variable called CNAME. And just to show you, I can echo CNAME like that, and we get the variable. So let's get this on our clipboard and make use of it in our CNAME shell script. So we need to swap out our invalid.sptuk.net for sub.domain. And then here we need to change this particular conditional to say if not. So the bang here, or the exclamation mark, means if not. So if the command failed. And we can change that for our CNAME variable. And perhaps our output text here should be something like CNAME did not resolve. And then probably we want to have some kind of indicator of what it was that was pointing to that particular CNAME. So let's give that a go and see how we do. So we'll take the subdomains.txt and we'll use a pipe to add it to the output of cnames.txt, and then we'll give it the apex domain of sbtuk.net. So it looks like this didn't quite go our way, but I'm sure we can figure out why. But we can see at least one piece of information here that was what we wanted. So let's take a look at our script again and see why we got all of these extra lines of output. Okay. So I think what's happening here is we are taking our output from this command, which is possibly empty, and we're putting it into the CNAME variable. Now, if we run the host command with no parameters, for example, and check its exit code, we can see it's 1 or it's non-zero. So every time we are attempting to look up this CNAME, if it's empty, it's failing and we're outputting this particular message. So we need to really add in a little extra check for that. So we can use another conditional here to say if 0, so I'm using these square braces now, and I'll tell you about those in a second. The string CNAME, then, can we use continue? I believe so. Then continue. And what continue means is go back to the start of this loop and don't run this particular piece of code. So let's give our script another turn now. We want to cat subdomains into our command. There we go. So in this case we get this one particular line of output, and if we change the domain, then we actually get one for Yahoo as well. But in this case the CNAME is for something.yahoo.com, so it's not something we could go and register and take over anyway. So let's take another look at our script and see what we've got. So we take a domain name as the parameter to the shell script, and we read standard input to get a list of subdomains, and then we run the host command to get a CNAME for that particular subdomain. We get just the lines that say they are an alias, and then we use awk to get the last piece of that line, which is the CNAME we want to look up. We check to see if it's 0. So I said I would tell you about these square braces. This square brace is a shell built-in, also known as test. And there's actually, believe it or not, a binary version of it as well, in user bin opening square bracket, which always made me laugh a little bit. So we use -z to say, is this 0 length, this particular string? And if it is, we continue. So we jump back to the beginning of the loop. Otherwise, that means it's not 0 length, so there is a domain to check. And if it does not successfully run through the host command, which is to say it doesn't resolve, whilst redirecting the standard out and standard error into dev null, into that black hole, then we were going to output or echo that the CNAME doesn't resolve, and we're going to mention which particular subdomain it was that pointed to it. So this is a much more complicated script, and again, it's not particularly fast or anything like that, but these kinds of tasks of I have some input and I need to use them for some process and then use the output of that process in another is such a common pattern, and being able to write these shell scripts quickly is incredibly useful. These are just my slides, and that's actually a slightly different version of the command. I solved it in a different way that time. So another thing I might want to do as part of taking part in a bug bounty program is go and fetch a copy of lots of URLs. So let's use our domain brute forcer against yahoo.com, for example, to get this list of domains. And I want to go and see what's on all of them. Now, here I have 11 of them, which I found out using the word count program. But, you know, I could have 1,000 or more. And rather than loading them all in my web browser, I'd quite like to use something like the command line tool, curl, which can be used to fetch web pages and any URL just about, to go and fetch them and put them onto disk, and then I can do some other things with them. And importantly, I can just leave it running to fetch all the things. So we know we can use curl to fetch URLs, and I happen to know we can use -o to specify an output file. So if we look at example.txt, we can see this is the HTML for example domain. And we know a little bit of shell scripting knowledge now, so we know about loops and we know about variables and some subshell tricks and a few other things. So let's see if we can put those together to make ourselves a little script to go off and fetch lots of URLs. So first off, let's make our list of URLs. So let's take our list of subdomains again, run them through our brute forcer for yahoo.com, and I'm going to use awk now, again, to prefix these all with HTTPS. So I'm going to say print HTTPS : and then a space and $1, which is the first field in a line of text. And then I'm going to use that, which way around is it, less than, greater than symbol again, to redirect the output of this command into a file. And I'm going to call it URLs. So if I open my URLs file, you can see I've got lots of links that, again, you know, I could click on them when there's only 11 of them, but if there's 1,000 or 10,000 of them, I really don't want to have to do that. Okay, so we have our list of URLs, and we want to write some shell script to go and fetch them and save their data. So let's give it a try. I'm going to call this one fetch.sh. And I'm going to put my shebang in there again, the hash, the bang, and then the path to bash, which might not be in user bin bash for you. It could be just bin bash, who knows. And I'm going to say while read URL do something, done, and that something I want to do was going to be a curl. And I happen to know I want the silent flag and the K flag to ignore certificate errors. And then there's going to be the URL as well. But also I want to save it in some file or other. And this is where things get a little bit tricky, because really I want to store every file in a different, the output of each URL in a different file. And you know, what should I name them? I can't pick the same name every time and say just -o output.txt, because they'll all get written to the same file, and that's not what I want. What I would really like is to store the output from each one in maybe the hash of the URL that's being requested, so that I know that they'll all be unique. So let's figure out how we can do that on the shell first. I'm going to use :sh to hop back to my terminal, and I'm going to say echo or some URL, example.com, for example, just as my test. And I'm going to pipe that into a thing called SHA-1. Oh, let's use SHA-256 sum, for example. So we can see that gives us the SHA-256 hash of https://example.com. And that's the part we want. We don't really want this dash here. So to get rid of that, I'm going to use awk, and I'm going to say I just want to print just the first part. So this little command here is going to give us the hash for a particular URL or any piece of text actually. So I'm going to hit Control D, which will exit this particular shell session and put me back into Vim. And in here I'm going to say file name is going to be equal to a little subshell, so $ in the brackets, and I'm going to swap this out for $URL instead of the hard-coded example.com, so that makes no sense. So now instead of output.txt, we can use the file name instead. So will that work? Let's give it a try. So, so I can stay in Vim. I'm going to run my commands from in here. So I'm going to hit colon and then exclamation, which is to run a shell command. I'm going to say cat URLs into my script, which will be / and then %. % means the current file. But we're going to get this fetch.sh permission denied, and that's because we need to use chmod to add the execute permissions to the current file. And then we can try again. So it looks like maybe it's doing something, but we're not really 100% sure what. No real output, so let's hop back to a shell and see what happened. We can see we have a bunch of files named after the SHA-256 hashes, which is kind of okay. I didn't really want them to be mixed in with all of my other directories, all of my other files in this directory. And also I kind of have no idea what's in each one, which is a little bit annoying. So let's hop back into Vim and see if we can fix those things. So the first thing I want to do is put them into their own directory. So before our loop, I'm going to use mkdir or make directory with a -p flag. And what that means is not only can I create multiple layers of directories at once like this, but also if the directory already exists, it won't complain. So I'm going to make a directory called out to store our output in. And then I'm going to prefix it onto our file name so that we put things into that output directory instead. So that was one problem. The other thing that I'd really like to solve is, that there was no output. I couldn't tell what was happening, but also when it had finished, I really had no idea what was in each file. Like, no way to know. So as well as running the curl command, I'm going to echo the URL. Actually, let's put the file name first and the URL, and I'm going to pipe that to a command called T. Now T you can think of as being like the letter T with the split in it. Takes some standard input and splits it in two, and one half goes to the screen and the other half goes to a file, and we have to tell it what the file name is. So I'm going to call the file index, and I'm going to use A for append man to just make sure that this file isn't overwritten every time I run this command. So let's run this again and see what happens. So now we can see some output actually showing us what's happening, and we can see the file names and the URLs for each file name. So that's quite a lot better. We can also see we have an index file now which has that same output in, so we're not going to lose it. And also we have all of the files grouped in one directory together so that we can look at them, delete them easily, or do whatever it is that we wanted. And this particular one is empty. So let's find one that isn't. So this one that starts with a 7 is quite long, so let's take a look at that. And we have lots of HTML to look through. Okay, so you can see we came up with something relatively similar to my original shell script. Not exactly the same, but that's okay. So really what we want to do now is look for some things in the output. So, you know, if I'd been loading these in a web browser and maybe looking at them with my eyes or something like that, I would have an idea for what to do. But maybe here I want to have a look at them in some more efficient way. So I might want to pull things out of them. So for example, I might want to have a look at the titles of all of the web pages that I've found. So I'll change into my output directory and I'm going to run a grep command and I'm going to try my best to explain it. So I want to look for this pattern title. These are HTML title tags with anything in the middle. Actually, probably, yeah, just about anything in between title tags in all files in this directory. And that's not going to work. We need to tell grep we want it to use extended regular expressions for that to work. And also, sometimes title tags are in all caps, or maybe in any case is still valid in HTML. So I want a case insensitive search as well. And you can see we got rather a lot of output here. Which, you know, doesn't really help us. By default, grep gives us the entire line that matched, and in this minified HTML we can't really see it, so we're going to use the O flag as well to give us only the parts that match. And here we can see we've got 4 of these files have title tags, and one of them indeed did have it in all caps. We would have missed that without that case insensitive flag. So we can use this to get a really quick overview of what files we've fetched and maybe which ones are boring and which ones are maybe a little bit more interesting that we want to go and have a look at. So other things I might look for are things like server headers. And we can't actually do that right now. So let's delete our output directory and make a slight modification to our fetch script, which we still have open. And that is going to be to add the verbose flag to curl, which will output headers as well as the request. But by default, they're not actually stored in the output file. So instead of using the -o flag, let's just use ampersand greater than to send all output, the standard out and the standard error, into that file name. And then let's try and run it again. So we'll cat URLs into our fetcher. We can see that worked. And if we have a look at some of these files, we can see they all have a size now. And we can see there's actually lots of output that curl gives us, but right down here at the bottom there's the server headers as well. And we can see that they all start with a less than and then a space, and it's right at the beginning of the line. So let's use that knowledge to come up with a list of all of the server headers that are in these responses. So I want to look for lines that start with, which is the caret here, and I want to use extended regular expressions. This less than and then a space, and then that should probably be sufficient. So we've got something that looks about right, but you know there's going to be a lot of duplication in here, so let's try and pare it down a little bit. So we can use the lowercase h flag to exclude the file name from the response, and then we can pass them to sort-u to get a list of all of the unique headers that have been sent back from the servers from all of these requests. And you know, we can look through them and see we've got server ATS here, or maybe down with these x dash there's some custom headers that might be interesting. Maybe we want to take a look at those too. Also commonly I'll look for subdomain takeover strings. So there's a great repo up on GitHub, the name of which escapes me right now, with a list of those. I also look for URLs and go and fetch them as well. So we can grep for URLs and then pipe them back into our fetch script again to go and fetch them, which is a really nice workflow. A variety of different secrets and that kind of thing. They don't show up very often, but sometimes you get lucky. They're worth looking for. Also things like error messages, file upload forms, interesting base64 strings, those kinds of things I really like to look for. But sometimes really there's no substitute for just looking at everything and using your eyes. So I want to show you a little trick that I like to use when I have a lot of files. In this case, 11 of them, but oftentimes way more of them. And that is to say, I want to open all of these files in Vim. And I'm going to use vim-p, which I think opens them in tabs and with a star for all of these files. But that could easily be some subshell command to say, I want to find all of the files, maybe like above a particular size, or in many of the other things that find can do. So I can jump to the end of this file and then use :n to move to the next buffer. So Shift-G takes me down to the bottom, and I can just at a glance see what the contents of this file is. And I can actually quickly, relatively quickly, go backwards and forwards between them. One of the things that I also have personally is a little alias called vimprev or vimpreview, which I use, and that binds space and backspace to next file and last file to make it a lot easier to jump backwards and forwards between them. So whatever text editor it is that you use, if it can open lots of files, I recommend just looking at them using your eyes, because we humans are exceptional pattern matching machines, and we're really good at spotting anomalies, way better than computers, or at least I like to think so, especially in novel data at least. So far the things that we've been doing are all kind of relatively single-threaded. Pipes actually give you some level of parallelization for free. So when you have a command that's joined together with lots of pipes, all of those individual sections are being run concurrently. And if you have multiple processors, as most systems do these days, they're running in parallel too. But oftentimes it's not really enough. So I want to show you an example of how we could use a tool called xargs to speed things up by speeding up our subdomain brute forcer. So hopefully it's demo time. Now, before we start, actually, there is a really messy way we could do this, and it looks like this. I don't really want to use this method because it gets really confusing. I'm going to use a different method. So counterintuitively, what I actually want to do is make a new shell script, which I'm going to call sub.sh. And this one is just going to check for one single domain. So it's going to say if this domain resolves, and remember we want to redirect all of our other output into dev null, then echo the domain and end. And that's a really simple shell script, but it's going to come in really useful for us in a minute. So we made that file executable, and now we can run it against any domain we want. So sptuk.net, for example, that resolves, that outputs, but that other one we had, invalid.sptuk.net, which is the dangling CNAME, is not considered to resolve because the CNAME it points to doesn't resolve. So that's one part. So we can do this next part on the command line to start off with, but then we'll add it into a shell script afterwards to kind of make it official, to seal the deal, if you like. So I'm going to take this list of subdomains. Oh, I just realized I put that sub.sh in the wrong directory. That's fine. So I'm going to take my list of subdomains, and I'm going to use awk to add our domain onto the end of them this time. So I'm going to say $1 and dot. Let's go with sptuk.net. Why not? For example, and I do need to print that. And then I'm going to pipe this into xargs. And xargs' job is to take each line of input and run a command with it. And by default, it actually takes multiple lines of input and runs a command for them. So we're going to use -n1 to say only take one line at a time. But then we're also going to say use P, or big P, let's say 5, or you know what, 10. And that means run 10 processes in parallel. And then we can give it our sub.sh shell script. And that's kind of hard to see right now, but that actually happened in parallel. We probably maybe see with P1 it takes ever so slightly longer. With a list of subdomains this small, it's kind of hard to see. Maybe we should do one with a bigger one. Let's somewhat artificially make our list of subdomains rather a lot longer. 308 instead. That'll do. So with P1 we can kind of see them scrolling past relatively quickly, but with P10 we can see we've got through that whole list really quickly. And again, we're using this for our subdomain brute forcer, but it doesn't have to be that way. It can be for any script or other program that already exists that you should happen to use. So let's take this pattern, as it were, and apply it to a shell script. So let's make a new shell script called parsub.sh. We'll put our shebang in the top. And can we use this pattern here? Yeah, we could do. Let's use a while loop that we used earlier on, shall we? Yeah, why not? So while we read subdomains, again, we're going to do echo sub.domain, which we haven't defined yet. And domain is going to be $1. We'll make this executable. And now hopefully we can get our subdomains.txt into parsub, and then we just tell it yahoo.com, and it works just like that. Nice and fast, and we get to control the parallelism. So this particular one I've done here works in a slightly different way, but it doesn't really matter. The point still stands, and you know, it's a really useful technique to have up your sleeve. So just some other final bits and bobs. So use detach for long running tasks. You can also use screen, but I quite like detach. I don't think it's installed by default in Ubuntu, but we can say detach-c to create a session, which I'm just going to call ses, with some command in it. So the command bash, for example. And it doesn't really look like much has changed, but I'm going to run the top command in here and then hit control / to detach from that session. And now I can go off and do all sorts of other things. And in fact, I can open up a whole new shell and say detach-a and then the name of the session file. And I can see that top command that was running is in there. And that will run until I exit, or type exit, or hit Control D, or whatever. And detach will go away. That's really useful too. Vim is kind of a major part of my workflow, as you might have seen. Oftentimes, I don't do things directly in the terminal. I'll do them from in Vim so that I can edit pieces of text more often. I think that's a relatively well-known thing about me at this point. But also, when things get more complex, do consider a different language. And it doesn't really matter what it is. I like Go, but you might prefer Python or not Java, please. No, you can really use whatever you want. But Bash, while it is a remarkably expressive language in a lot of ways, when things get very complicated, especially around string manipulation and different logic flows, things get really tricky really fast, and they can get really difficult to debug too. So really do consider using a different language. So that's it from me. I hope you enjoyed listening, and I hope you learned something too.